So what I want to finish off today with is just talking about where acids and bases come from. This is more of a chemical kind of situation, not necessarily a historical, but what types of elements produce acids and what types of elements produce bases. So let's start by talking about how acids are formed. So synthesis of acids. And it turns out, and this is again a very simplistic representation of how acids and bases are formed, all right? When we get into some of these other elements that are not near the edges of the periodic table, there's some odd and weird reactions that take place that don't necessarily produce an acid or a base the way I'm teaching you here. So these are for the simplest types of elements that produce kind of the simplest acids. Again, there are far more complex type versions of some of these things, especially when you get down here into arsenic and tellurium, and aluminum does some odd things in the reactions. So it's not as simplistic as this. This is, again, just a very much of an introduction for you guys. So it turns out if you take a nonmetal and you burn it, a combustion reaction, and you produce the oxide of that nonmetal, I think a good example would be carbon. All right, if I take some carbon and I burn that carbon in oxygen and produce carbon dioxide, and then you take that oxide and you dissolve it in some water, or you react it with some water, you end up with an acid. So you take that nonmetal oxide, whatever you've got after you've burnt the nonmetal, you react it with some water, and it ends up producing an acid. So the main thing, how do you get acids for you guys? You take a nonmetal, you burn it, you take that product that you get, you mix it with water, there's a reaction with the water, and it produces an acid, okay? A classic example of that, and I prefer to write these types of things. Again, I'm not a fan of the animations here, but we'll follow the animations. I like to write on the board myself. But a classic example is, again, carbon, as I've been talking about. Burn it in some oxygen, produce some carbon dioxide, and then take that carbon dioxide and react it with some water. And we've already seen this second reaction. Actually, all of these reactions we've seen before. Put the carbon dioxide with water, and you end up with that H2CO3. And I guess we could take this opportunity to review some of the different types of chemical reactions, all right, that we've already seen. Some of us just did our quiz. I can actually hand those back, remind me near the end. What type of reaction is this first reaction? What do we call this type of reaction? Going back to the week before the break. Yep. It is indeed a synthesis reaction. It is a synthesis. It can also be categorized as this. There's a second category it can fall into. What else is that reaction also known as? Keegan's the only one who's coming to play the game here today. All right, Keegan, what do you got? It's also a combustion reaction. Very nice. Combustion. This isn't in the note, is it? You're not like looking on a phone and has the answers on it, do you? Is it? It's not in the note. Those of you writing ahead, because I'm giving like Keegan lots of accolades for all these correct answers. I just want it to be legit. Legit? It's legit. Good. Second one. What type of reaction is that? What do we call that reaction when we have those two things reacting together to produce that single product? What do we call that? Two things becoming one. It's also a synthesis. It's also a synthesis. So this is also a synthesis reaction. Even though it's made up of two compounds coming together to form one compound, it's still a synthesis reaction. The only requirement for synthesis is that two becomes one. All right. And we've already encountered this Does anybody remember what the name of that acid is? We talked about that yesterday. This is a carbonate ion, and then I added the H's to make it blank acid. What is that acid called? Anybody remember from yesterday? And it is okay to flip back. The boss is flipping back right now. He's looking back at his notes. So we'll pause for tracking of the information. This would count as what we call an oxyacid. I should have did a quiz today on naming acids. You would have known this. Have you found it yet? Abbas, you got it yet? Abbas has found it. What do you got? Carbonic acid. This is carbonic acid. Where do we find carbonic acid? Yep. 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 Oh, para-acetic acid. Yep, I've heard of that. We know what acetic acid is, and I've come across para-acetic acid. Is it per-acetic acid? It's per-acetic acid, P-E-R. And I've come across that. I came across it at a brewery tour. All right, so we were touring a brewery, and they had a big vat of the per-acetic acid, and it is used as a disinfectant. So it would be killing germs of some sort. That's cool. That's exciting. That's good information right there. All right, so carbonic acid found in pop. Let me just show you that reaction here. All right, and I hope this works. I haven't tried this before. We do a lab sometimes in another class where we do create the acids, and I'm going to try to do that here right now. And my source of carbon is just going to be a splint. So when we do this lab in the grade 11s, we will actually have an oxygen atmosphere that we've caught from an oxygen source. But I'm going to just use the oxygen in the air just for simplicity. And I'm going to try to trap the carbon dioxide that's formed using just a watch glass like that. Carbon dioxide is, its gas is heavier than air. So when I produce the carbon dioxide by burning the splint, it's going to stay in the beaker, and it's not going to try to escape because it's heavier than air. It's going to settle down into the bottom. So actually, I don't really need the Bunsen burner for this because I can light the splint with just my lighter. And actually, before I do that, oh, here, hold on, I'm not ready. Let's put some water in it first. And let's put some bromethymol blue in it. Because I want to be able to prove that it is that it reacts. So bromethymol blue in some water. Let's give it lots so we can see it. And there we can see it's bluish, indicating what? What is this water behaving as right now? What's that? A base, because a base is blue. It would have been nice that it was more green because that's water coming out of the tap. What should the pH of this water be? Just coming out of a tap? 7. Should be around 7. So this should be a little more green than blue. I guess it's kind of turquoisey a little bit, maybe bluer than turquoise. So this water seems to be a little more basic than acidic. That's okay. So now what I'm going to do is I'm going to take the splint and I'm now going to burn it. Now I'm ready. And I'm going to let that splint kind of burn in this area for a while. So it's gone out. It's gone out because I've used up some oxygen. Let's take that and swirl the gas into the liquid. So I'm trying to get the gas to go into the liquid, the carbon dioxide gas. And by swirling it, I'm making the gas kind of mix with the liquid. And you can see here, did we get to yellow? I guess we got to yellow. So that carbon dioxide gas, simply by burning the splint, reacted with the water that was in there. The indicator then resulted in showing us that it turned into an acid. So I could do that with other non-metals, all right? Another experiment we do with the grade 11s is we'll burn some sulfur. We'll do the same thing. It works very well, but sulfur really stinks. So when we do the sulfur experiment, we want to do it in a fume hood so the fumes can be gathered up. Because if I burnt sulfur in the room like I burnt the carbon here, you'd all be pinching your nose and be like, oh my goodness, you know, it smells like a stink bomb. If you've ever smelled a stink bomb, it's the sulfur that is in the stink bomb that results in that terrible smell. No, we don't want to stink out the room. All right. So, we could, but we're not going to do that. Just relax. Keep all those ideas in your head there, Thomas. I know there's things turning in your head at this point. Just save them for another time. Nope. It's all right. I have access to lots of sulfur. Thank you. A rotten egg produces dihydrogen sulfide, or hydrogen sulfide, H2S. And hydrogen sulfide really stinks. All right? That's what makes a rotten egg smell really bad. Now, hydrogen sulfide is also a flammable gas. So what they'll do with hydrogen sulfide is they'll put it in with natural gas or propane. So if someone were to turn on the natural gas and to leave it on, which would be dangerous, you smell the natural gas as being stinky. You know what I'm talking about when somebody leaves the propane or the barbecue on and it doesn't, light and you can smell it. Has anybody ever noticed that? Yes? No? You've never noticed that? Okay. Well, it does. It smells. And that's because they put hydrogen sulfide gas in with the fuel because the fuel is odorless. So let's say you had natural gas in your house and you were, heating your house with a natural gas furnace, but for some reason the furnace doesn't activate properly and it releases natural gas into the house. That could be very dangerous because if somebody were to light a lighter, it would blow up the house. So what they do is they put hydrogen sulfide in there so you can smell it. It makes it stinky. And that's what you're smelling when you're smelling propane or natural gas. Question?
I just, yesterday, there's a social and I get, it's radio cans with natural gas.
Correct. That's exactly what that is. Yeah. There's a commercial out that says, you recognize an emergency when you see it, right? And they talk about the water being all over the place. Is that the one you're talking about? But you can't, but do you recognize when you smell it? That's exactly what they're talking about. That rotten egg is the hydrogen sulfide that they put in the gas so that you can smell a gas leak. If they didn't put it in there, you wouldn't smell it and you'd be in danger. All right? So we got onto a discussion about stink bombs and rotten eggs because, remember, we were talking about sulfur being burnt and it would do this reaction very nicely. It actually produces sulfuric acid when we do that particular reaction, okay? And it's stinky, and so we're not doing it. All right. Now let's talk about how bases are made. When you take a metal and you burn it, and take its oxide and have it dissolve in water, it results in a base. Let's see if we can finish this. Well, no, many of you guys are looking at the answers already. I was going to say, let's see if we can finish this without clicking ahead, but I'm just going to click ahead. So potassium will react with oxygen to produce potassium oxide. And folks, when we're getting formulas, again, this is kind of a little bit of a review. Many of us are being quite lazy. I saw it on our balanced chemical equations for our reactions on our single and double displacement labs. When we get the formulas, we have to take the charges and we have to cross the charges over in order to get the proper formula of the compound. All right, many of us are just putting letters out there, and that is not going to cut it. All right, we've got to cross it over to get the K2O. All right, and then we have to balance, obviously. In this case, we needed 4 Ks, and we needed 2 K2O in order to take care of the O. When we react the K2O with water, we will ultimately get KOH, which is potassium hydroxide, and we're going to get 2 of them. and some uses there, and I'm not that concerned about the uses. It's used in making soap, fertilizer. It's also found in something called potash. The POT of potash comes from potassium, all right, and various things. I do have an example of a non-metal. So let's take a look at that one. We'll get this out of the way. Oh, you know what? I'm not going to use a new source of water, and that's because it already started out as blue, right? So if the water starts out as blue, then that's not going to get us anything. So let's use this that's already slightly acidic, so we can see if the metal oxide does react with the water to make it more basic. And the metal that I'm going to use is magnesium. And we saw this when I earlier on demonstrated. Let me grab some tongs here, if I can find some. We saw this when I early on demonstrated combustion of magnesium. And it makes a very bright light. And I told you that they suggest that we don't look that closely at the light. And I said you can do whatever you want to do. So again, I'm going to burn this. And I'm hoping I can catch the ashes before they fall off. So bright. So I've got that white powder. I don't know if you can see it there. There's a white powder there. I'm going to knock that off in there. Get in there. All right. Let's get that out of the way. And now I'll take the other side of the splint here, and let's mix that up. And stir that up. It's not very soluble, so we might not get a good action on this one. I'm hoping we do. I think maybe we've got too much acid in here. The issue is that the oxide that I've formed doesn't dissolve very well. Am I getting slightly more green? So the magnesium oxide is a base, is a solid, and that solid doesn't dissolve very well, so I need lots of it. Let's get that out of the way. Let's burn another piece. Let's see if we can get a little more out of this. Oh, you know what? I want that powder. Come on. Turn bluish. Do something. Chemistry also takes some talking to. Are we getting a little more blue? We are. We're green at this point. If I had one more piece, we would likely be able to shift it over to the blue. Anyway, I don't have any more pieces, unfortunately. So I'm hoping that you see there that by me adding that base, and what I did differently the second time was I caught that powder, that smoke that was leaving. That's also magnesium oxide. It's fine little particles because they're smoke particles as opposed to the big hunk. And those fine little pieces are able to dissolve a little better than the big hunks. So I tried to catch some of those fine little pieces and get them in there. So we went from yellow to greenish, which means we were shifting towards the base side of the pH scale, and that's because it was starting to neutralize that acid. So if I had done that a few more times, I think we would have successfully made it over to blue. But I think that's a better demonstration than me starting with water that was already blue. That really wouldn't have shown us anything. That's shown us that it is slightly basic. So metals, we can, if we burn them and we take those oxides and we dissolve them in water, then we have a base. All right. So let's talk a little bit about how this can exist in nature. And I mentioned this a little bit. Sulfur is often released into the air through combustion of various fuels. Yep. There are sulfur compounds in there, correct? Yes. The reason your feces smells so much is because the sulfur in the food that you're ingesting is not used by the body. And so it is passed through and kind of concentrated, and that's why it stinks. Correct. If you want to think of something else that's really stinky, like a skunk spray, it also contains sulfur compounds. Typically, things that do not have a pleasant odor, that have that distinct odor, it's due to the sulfur that's in those compounds. So that's correct. Correct. So Thomas, trying to be funny, actually said something very scientifically pertinent. Nice job. So, sulfur is often found in many fuels, often in coal, and diesel fuel has quite a bit of sulfur in it, all right? Gasoline, not quite as much. I'm not sure why. It must be the processing kind of process. And when those fuels are burnt, all right, not only does it produce things like carbon dioxide when the fuels are burnt, but it also produces sulfur oxides. It typically starts out as sulfur dioxide, which then reacts again with extra oxygen in the air to produce sulfur trioxide. And I know this is not balanced. Let's not worry about the balancing right now. Actually, we need a half in there. And that sulfur trioxide then reacts with the water, and that produces, well, what is this acid called? H2SO4. This is a sulfate. We're going to add H's to it. What kind of acid is it going to become? Sulfate. What does it become? Asking you to think of a name. We're flipping back. Yep, that's sulfuric acid. Sulfuric acid. Sulfuric acid is a strong acid. All right, carbonic acid is a weak acid. Whenever you ingest an acid, it's going to be weak. Vinegar is a weak acid. Carbonic acid is a weak acid. We don't want it to be strong, or it's going to, it's going to actually react with your insides. Sulfuric acid is a strong acid. All right, and this results in what we call acid rain. Morning? Nope. All right. So in the end, this results in what we would call acid rain. Acid rain was a big problem in the 70s and early 80s. And in our video, the video I'm going to show later on was actually produced in the 70s and 80s and talks about this problem. Since then, they've developed ways to remove the sulfur from the fuels and the coal, and that has made burning those things a cleaner thing. And so we have less incidence of acid rain than we did back in the 70s and 80s. All right? Okay. If you have highly acidified bodies of water, all right, like a lake can become acidified due to the large amounts of acid rain, you can put in some calcium oxide. That's sometimes called lye, all right, L-Y-E. And it will react with the water, and it will produce a base, which will then neutralize the acid, okay? And again, they'll show that in this video. This note, again, talks more about what was happening in the 70s and 80s with a lot of acid rain being produced by burning coal in power plants. Just kind of at the same time they were developing good nuclear power plants, there was a lot of coal being burnt in order to produce the power. Now we have many alternatives to produce our power with wind and nuclear and solar. They're attempting to kind of phase out this burning of coal because it produces a lot of pollutants. Again, just as a review, let's go through the types of reactions that we've got here. The first one, what type of reaction is that? What type of no, you're done. Good job. What type of reaction is that first one? Bailey, what do you think? What type is that? Synthesis? It's a synthesis, or what else? It's also known as, yeah, it's also combustion. Very good. Combustion. Second reaction, what type of reaction is that? What type of reaction is that? Looks like it's Pick on Martina week again. I forgot about that. I'm noticing my regular people are gone. So, Martina, what's the second one? Synthesis, correct. Two become one. Excellent. And the last one, what type? You got two possibilities. There's two correct answers to this. Taylor, what do you think? Yeah, you're right. It's a double displacement. The Ca is going in for the H. Double displacement, or what else could we call this reaction? And we just learned this word recently. We didn't learn it when we learned about the reactions. We just learned it yesterday. Neutralization. This is also a neutralization. Neutralization. An acid and a base resulting in water, and then the salt in this case is calcium sulfate. All right, so neutralization reactions are double displacement reactions. Excellent. So there's a little bit of reading about an antacid. I want you to go and I want you to read that little section and just define what an antacid is. There's a little bit about acid rain that I just talked about a little bit. You can answer those questions. That's kind of like the homework for today's lesson. All right. Right now, I'm going to stop my video so I can show you the little video summarizing acids and bases. And then I'm going to do a brief little kind of review about some of the main things that I'm finding that I'm seeing you guys struggle with before we roll in the test, and then I'll let you work. Okay? Yep. Just hold off till after the video. All right? Yep, just hold off. Okay, I want to go to one other slide here for a moment before I show you the video. Down here at the bottom are your chemistry review questions. You can write that down as well. This link right here, you don't have to write down. That's my link to the video that is online. So the chemistry review questions out of the textbook. I'm going to freeze that so I can stop my video for a moment. Save.